So I know most of you aren't shipping the latest version of Node constantly. Like, we're all just chilling on LTS. I know I'll be on Node 20 for quite a bit. But for those who are, you might have been in for a rude awakening a couple days ago when Node 22.5.0 broke most applications. How did Node break, and what would have caused a break like this? Well, this is an interesting one because the goal wasn't obviously to break things, it was to massively improve performance. And a character that's been in a lot of our content in the past is the one responsible, but he's done a great job owning it. And I want to dig in, not just because it might affect the tools that you're using, but these things tend to teach us a lot of valuable lessons about production software, especially software that's being used by millions upon millions of developers every single day. So without further ado, let's dig into the post-mortem for this bug. For those who are not familiar, Yagiz is the developer who has been trying their hardest to make it so that Node performs as fast as other solutions, like Bun. And he's worked very, very hard to make some massive wins. Sadly, his most recent efforts caused an unexpected bug, and they've since patched it, but he did a great covering of what led to this, so let's talk all about it. For those who are unfamiliar, a recent change of adding V8's fast API to fs.closesync broke almost all applications in version 22.5.0. The goal of that PR was to significantly improve the performance of this function and speed up applications like NPM. Unfortunately, I broke it. For reference, here's the root cause of the incident. So here's the pull request that got merged. It's always good to look at the original PR just to see if it got any pushback, if anybody caught anything interesting in the code review process. We're seeing here, if fallback's true, would it be called twice? Missing something, claimed it was valid, got an LGTM from Theo, remove unmanaged, got a bunch of approvals. This is unsafe, think I got it. The I think I got it before merging is a little scary. Nothing too interesting here, just some decently thorough code review and the reveal that the plus minus here isn't particularly big. For those who aren't familiar with Fast API, TLDR is the way that V8 can access native C++ code without having to go through as many layers of bullshit. So if you want to do something really quick, the Fast API is the way to do that. It was built into V8, which is how Chrome runs JavaScript. It's the JavaScript engine used in Chrome and also used in Node. And more of Node is starting to take advantage of the Fast API in order to make certain things more performant. One of the places where it's most useful is things like file system and I/O. So you're trying to read data from the file system, doing more and more of that natively through things like the C++ bindings, rather than parsing all of that in the JavaScript layer, tends to be much faster. Makes a lot of sense. I'm getting some useful corrections in chat. These are only the FFI calls, if I'm familiar. Technically, this is the ECMAScript compiler. It compiles to C++ and ASM. Does not run the code. V8's technically only the compiler. That's a bit too deep for how I like to frame these things. While the implementation details of V8 are, to say it lightly, complex, it's best to think of it as the engine for the JavaScript code that turns it into something that actually runs on your computer. Anyways, what is the problem? What went wrong here? Before diving into the technical implementation, let me explain what these bugs were. There's actually two bugs that caused the issue. The first issue is this crash, which occurred with the error message, V8 object get creation context checked. Yes, get creation context checked. No creation context available. This error was caused by libinternal fs read context.js. We were destructuring the result of internal binding fs, which caused the creation context of the function being unavailable. Interesting. So previously, they had it like this, where they were taking the value out using destructuring. So if you're not familiar with the syntax, I don't know why you're watching this video, but this lets you take a key out of an object. So this returns a bunch of things. We don't care about them. All we care about is close. So we're just taking that key. But this apparently causes the actual context of where that's created to be lost. So if we do it like this instead, where we get the whole object and then we're calling .close on that, we don't lose the binding. Good to know. And this apparently broke NPM, which is where things get scary. The second issue caused by the addition of the V8 Fast API call for fs.closesync. At least that's what I thought I was adding the Fast API for. Unfortunately, adding a Fast API to close function, even though the Fast API had a function signature of fast close, it was still getting triggered for fs.close. Interesting. So fs.close was hitting this new path, even though it was only meant to update close sync. Very interesting. Fortunately, this had been the expectation from my side, and unfortunately under optimization, causing V8 Fast API to trigger it and causing NPM to fail. So my guess is that the code underneath that close sync was calling was the same as the code that fs.close was calling. And since close sync is sync, you don't have to resolve anything. Where fs.close, you have to call the dot then and resolve it, or use all the crazy things that we had in Node before we had promises. And because the same code is being used for both, and this fast implementation didn't call the end calls, fs.close never exited, which is why we got the error that the exit handler was never called, because this was hitting paths that were supposed to be sync, and those sync paths didn't call a close. They just returned a result. Since fast clone didn't receive, because fs.close takes a callback. Again, that's the key here. There's no dot then or promises in old Node stuff, and fs.close and most of the FS APIs. If you want them to work with promises, you have to import them from fs/promises. But the default fs.close, which is almost certainly what things like npm use, they pass a callback. And this callback was never called because the code underneath assumed it was a synchronous path, not an async path, because again, somehow, unexpectedly, fs.close and close sync were hitting the same code path, not to the knowledge of Vigas. Since fast close didn't receive any functions as a parameter, we weren't executing it. This resulted in fs.close to be executed in the fast API context, and it caused npm to fail since it was expecting the result of the close operation. Moving sync and non-sync versions to two different C++ functions and adding a fast API to sync the version fixed this problem. Node has a project called Canary in the Goldmine to catch unintended bugs that might affect the ecosystem like this. Fortunately, recently we discovered that even if there were failures, our CI jobs were successful. This issue is currently being investigated under the following. The solution is that they need better testing for the V8 fast API implementations. There's some unintended consequences of these additions, and unfortunately, it requires more thorough pull request reviews. Yeah, this showcases so many things that are important to understand as a developer. The first one is that these internal function definitions, it's hard to know everywhere that a given function is being called. It was not intuitive to anybody who did the code review that close sync and close hit the same path. If we go back to that original pull request, it does not look like anybody caught this. Yeah, even just looking at this briefly myself, just quickly looking at this, I would not have intuited that this function was going to affect both. It is a little sus that it's named close, but there's no code in here that actually called the function callback. Yeah, we have environment, length code, if get validated function return. None of that was touched or deleted. We literally just made this static void close function, then wrote a separate fast close function underneath that doesn't take the callbacks. Oh, here it is. This is where things would have broken, where instead of setting method close, we set fast method close at fast close. Okay, here's the break. When we actually set the method in the node file cc, which is where a lot of these things are bound, we are binding a set fast method instead. But since we're binding it to close, this binding is what's being used in both places. Where this starts to get confusing is there isn't a clear path from where this node code is being called that trails all the way to where this method is being bound in the C code. And this is where things start to get messy with large projects, be it an application with a different backend and front end, or something like Node, where there's lots of parts and lots of different languages. Going from the C++ code in this Node file API set and tracing this set fast method call back to the different places that are calling it is non-trivial. And since this method doesn't have the callback option that fs.close expects, things start to fall apart. But there's no real way to identify that with things like, I don't know, a type checker, because you can't honor these definitions from that low-level C++ code all the way to the place where it's being consumed in JavaScript. I can see why this would happen. And we register it here. Fascinating. Also just fascinating that nothing caught this, and most importantly, the importance of your CI. The canary in the gold mine process that they have to catch these types of mistakes is not working. And this to me seems like the biggest failure. This is the final layer, the final safety net, so to speak, that prevents these types of things from shipping to users. And knowing that there's effectively a giant hole in the safety net seems to be the ultimate cause of this problem. Very sad. Thankful this happened in something that wasn't LTS and they were able to get a fix out as fast as they did. I am curious about the code changes here. I'm assuming they just made two versions of the method. Yeah, function close sync binding dot close sync. Interesting. Okay. So previously, the close sync function in libfs was just calling binding dot close. That's kind of hilarious. That close and close sync were the same thing, but close sync just returns the result. That's kind of funny. I see why they had to bind this separately and why this would happen. The idea that close and close sync are actually the same code under the hood is not something that would have been intuitive to me at all. To be fair, I'm not a Node contributor, but yeah. In here, the big change is we have two separate close functions now. We have close and close sync, both in C++ code, and then those are bound separately, as it almost certainly should have been before. But yeah, that would have been super unintuitive. I never would have guessed that close sync internally was just calling binding.close. Good to know. The other close method's a few lines up here. So this one, if there's a callback, then we bind it. And if it's not the default close callback, then we bind it. Then we do the request, and then on complete, we call the callback, and then we close after. Makes sense. But these are both calling the same binding. Never would have guessed. Today I learned. I'm sure not the only one that was surprised by that, and I am curious what y'all think as well. This is one of those rare instances where something went wrong, but we know all of the info, we reduced the potential for damage, and we learned a lot from it. Let me know what you think, and until next time, peace nerds.